circles, tangents and normals. In this circle, the line segment AB has a midpoint which is the center of the circle. So if you're ever given coordinates where you know that the line that links 2 points together is a diameter, and you know the coordinates of these 2 points, when you work out the midpoint of these 2 points, that will be the center of the circle. So applying some basic coordinate geometry to work out the midpoint of AB, we get the center of the circle. In this question, you're given the coordinates for the center, and you're given the coordinates for one point on the diameter. To work out the coordinates for point B, look at the x-coordinate for A and the x-coordinate for the midpoint. To get from 3 to 8, you're adding 5. Then you do the same again. Add 5 again. So 8 plus 5 gives you 13. And then do the same with the y-coordinates. So to get from 5 to 3, we're subtracting 2. And then do the same again, starting from 3. If we subtract 2, we get 1. The gradient of the line segment AB. Change in y divided by the change in x. So if I start from point A, then change in y is 5 minus 1 divided by the change in x. So starting from point A again, 3 minus 13. 5 minus 1 is 4. 3 minus 13 is minus 10, which we can cancel down to 2 over minus 5. And this minus here, if we bring this out, we get minus 2/5. To work out the equation of the line that goes through AB, and AB was the diameter of the circle, so this line here is a normal to the circle, we need the coordinates of any one point on the line. So we can use the point A or B or even the midpoint. I'm going to use the point A for this example. We have the gradient, minus 2/5, and then using this form for the equation of a line, and x here is 3, y is 5, and the gradient m is minus 2/5, so we have all this. And to get rid of the fraction here, if we multiply both sides by 5, then on the left hand side, if we multiply these terms by 5, we get 5y minus 25 is equal to minus 2 times x minus 3, and expanding the brackets on the right hand side, we get minus 2x, and that's a minus times a minus to give us this. And then if we take all the terms to one side, we have 2x plus 5y minus 31 is equal to 0. And this is in the form ax, where a is 2, plus by, where b is 5, plus c, where c is minus 31, is equal to 0. And because AB is a diameter of the circle, then the line that goes through AB is the normal to the circle. So what we've worked out is the equation of the normal that goes through points A and B. Okay, moving on. a tangent is perpendicular to a normal. So if we want to work out the equation of the tangent, we need the coordinates of one point on this line, and we need the gradient of this line. Now if the gradient of the normal is minus 2/5, a line that's perpendicular to the normal will have a gradient with the opposite sign, so it will be positive, and you have to flip over this fraction here, work out its reciprocal. So the tangent has a gradient of 5/2. So using the coordinates of point B, which is on the tangent, and the gradient of the tangent, and then the form y minus y1 is equal to m times x minus x1, so we're going to use this. Then we have this. The y coordinate here is 1. So we've got y minus 1 is equal to, the gradient is 5/2 here, times x minus the x coordinate, which is 13. And then if we multiply by 2 here to get rid of the fraction, and the 2 will cancel on the right hand side when we multiply by 2, and then we can multiply that 5 with the x minus 13 to get this. So these two multiplied by 2 give you 2y minus 2, and these two multiplied by 5 give you 5x minus 65, and then taking all the terms to one side, and preferably keeping the x term positive, gives this. So this is the equation of the tangent to the circle. And as you can see, we have not used differentiation anywhere. So when we're looking at circles, and we're looking at gradients and tangents and normals, we're typically not using differentiation here. We're just using basic coordinate geometry. So this is what we've just worked out. This was our circle. That was point A here, point B here, the midpoint, and then we worked out the gradient of this line, and then we worked out the equation of the normal, and then we worked out the gradient of this line, the tangent, and then we worked out the equation of the tangent. So in all of this, where have you used differentiation? Nowhere. It's all coordinate geometry. Which of these circles shows a normal? Now, a normal must pass through the center of the circle. So this line here is passing through the center. So this line is a normal to the circle. It's perpendicular right here to the circle. So this one is a normal. This line does not go through the center. The line is not a normal. This line here is not going through the center. This is a tangent to the circle. It's not a normal. This one here is a normal. The line goes to the center of the circle, and it's perpendicular to the circle here. That is a normal. Okay, a new example. The gradient of the line AB is equal to 3. So the gradient for this line is equal to 3. Now this line here, AC, is going through the center of the circle, so it's a diameter. If that's a diameter, then this part here of the circle, this is a semicircle, and the angle there is therefore 90 degrees. This is a right angle. Yeah, angles in a semicircle are 90 degrees, property of circles, which means the line AB is perpendicular to BC, because that's 90 degrees there. So the gradient for this line will be, well, change the sign, and then the reciprocal of 3 there. A new example. In this question here, we're trying to work out the equations, so there's two of them, of the horizontal tangents to this circle. So horizontal means it's got to be a line like this. So there we go, that's one horizontal tangent to the circle, and there's another one down here. So what's the equation of this line and this line? Now the radius of the circle, which I've not given you so far, is equal to 3. If the radius is 3, that means the distance from the center straight up to here, that distance is 3, which means the coordinates here will be 3. That's the y coordinate 5. If that increases by 3, you get 8. And if you do the same going down, the coordinates for this point will be 3, and then that y coordinate is 5. If I subtract 3, I get 2. Now, horizontal lines have the same y coordinate at every point on the line. So the equation of this line is y is equal to 8, and this line is y is equal to 2, based on the y coordinates of every point on those lines. Okay, now with the same circle, to work out the equations of the vertical tangents, so again there's two of them. We have one here, and there's another one here. And if we look at the horizontal distance between the center and this point here, that's on the vertical tangent, well, that distance there is just the radius of the circle. The radius is 3. So the coordinates for this point, if I start with an x-coordinate of 3 and subtract 3, because I'm coming to the left-hand side here, the coordinates for this point will be 0, 5, and adding 3 going to this point here for this vertical tangent, the coordinates here will be 3 plus the radius, that distance there, so 6, 5, and vertical lines have the same x coordinate at all points, so the equations of these vertical lines is defined by the x coordinate. So this one is x is equal to 0, and this one is x is equal to 6.